Fuck no, I'm not giving Jeffrey all my money. Update, this is Guido from the future, and I bought all the parts from Amazon, so like I ended up giving Jeffrey like $300. Anyway, back to you, old Guido. Alright, so lately I've been getting really into tennis, and it is such a fun sport to play. And of course, I want to get as good as I can. But to do this, I do have to train. But there's only a slight issue. I don't really have any friends to play with. But what I do have is engineering. So, I'm gonna have a bucket with a rotating bottom, which will actually act as the feeding mechanism. And then I'm gonna simply have the balls drop from that bucket and feed into a mechanism that has flywheels. At first, I was considering just 3D printing some custom design wheels, but that would definitely take way too much filament, and that would be way too expensive. After doing some more research, I landed on these things. These are Vex Flex wheels. The good thing about these wheels is that they actually flex, as the name says. What this would allow me to do, first of all, get a better grip on the ball when it goes through both of them, right? Because it would actually compress on the ball, and it would also not put so much pressure on the axle, because the axle would not be taking all the shock from the ball actually going through the wheels. So to connect them both, I'm actually gonna need a shaft coupling and a shaft. So how this is gonna work is that I have my shaft here, my coupling here, and that connects to the actual motor. The only issue is that this circular shaft would actually slip off of any kind of wheel I use. So these shafts are out of the question.
And up next, a cylinder. I think that goes in the square hole. Now we've also got the semicircle right here. Do you see a slot that would fit the semicircle? That's right, it's the square hole.
As we all know, the squares go into the circles. See where I'm going with this? So basically, all I had to do was buy a different coupling that has a different size for the entry and the exit, and now my square bar actually fits into the motor. But this still didn't solve the question of how the hell am I gonna get this wheel with this big ass hole in it to actually stay in the axle. Well, lucky for me, the Vex Robotics team at my school already had a solution for this, and that is this piece of polycarbonate that I laser cut to actually fit my square axle, right? I'm back. After much screwing, we have this. Pretty fancy, right? That took a hell of a lot of screwing, but now we see how my square axle actually fits into the wheel and it can spin. Now combining that with the shaft coupling, boom! Alright, let's take a second to talk about the actual body of the machine, where all of that is going to be mounted on. So, at first I was thinking of something like this, right? The wheels would come across here, and I mean, it's made out of steel, so it should be pretty sturdy, right? That's not going anywhere. Well, this way, it's not moving, but this way, it's a fucking mess. So after much thinking and considering, I went back again to the very basics. Wood. Wood is just such a versatile material to work with. Like, yeah, I'm not gonna have wobble issues with this wood. So let's build this thing, shall we? I love this thing.
But do you remember how that ended? Oh, okay.
Alright, so I've been procrastinating building this shit clearly. It was almost done like 2 months ago, but we're finishing it. Anyway, you guys are about to see the final product. Alright, I don't feel like doing an outro, bye.